Hi, everybody. Thank you for the messages. I saw that many of you are, we know each other. And I am here with Christian and Professor Di Prampero. I'm going to introduce them later, and also Moren. We just want to tell you why we are here. And it's because last summer with should be Moren and Professor Di Prampero, we presented the introduction of the in situ profile in our web app. So we have the possibility for 1 year from some user of ours to use the future and collect some data and to make some reason. Professor, thank you very much.
Thank you, dear colleagues and friends. The aim of my presentation is to discuss with you briefly some practical aspects of the acceleration speed profile. Some aspect that Professor Morin will take on later in much more detail. But before going into these matters, I would like to briefly introduce Professor Morin himself, who, after a national diploma in track and field in 1988, he got a university degree in sports and training science at the University of Saint-Étienne in France. He then, in 2004, obtained a PhD in human motor function, jointly awarded by the University of Saint-Étienne, France, of course, and the University of Udine, Italy. He then, in 2011, he got a research director degree at the University of Saint-Étienne, la Université Monet Saint-Étienne, and now, where he is now a full professor. But I want to go back to the year 2005, when Morin and Jean and Alain Belly of Saint-Étienne, together with me and two colleagues of the University of Udine, we published a paper on the new method to determine the energy cost of accelerated running, of sprint running, based on the analogy between the accelerated or decelerated running on flat terrain with uphill or downhill running at constant speed. And this study was partly a fallout of the PhD of Professor Morin, jointly awarded, as I mentioned before, by our two universities, where he produced a thesis that was passed with highest honors, a thesis on mechanical factors of sprint performance assessed with new measuring methods. Now, thanks to this paper in 2005 and the joint effort of the Christian Osniak and the gpexe team, the Exelio team, we are now in the position of assessing running velocity and acceleration as a function of time throughout any given period of time. And this allowed us to show that this relationship, as measured during maximal accelerated sprint, is a linear relationship, wherein, of course, initially the acceleration is very high and the sprint practically zero. And as the time goes by, of course, the speed increases and the deceleration decreases to attain zero when the maximal speed is reached. But we, thanks to a new study and appropriate GPS system, of course, the gpexe is ideal to this method, as will be shown in detail by Jean-Benoît Morin in the next speech, this relationship, the acceleration speed relationship, can be determined without the need of maximal tests, which are not well accepted by the athletes, coaches, and trainers. Rather, it can be detected, it can be assessed quite reasonably from a number of regular training sessions, or if the gpexe is held also during the match, also during matches. Now, this figure, which we have underlined, shows exactly that. It presents a series of acceleration versus speed profile of 16 soccer players of an Italian Serie A team, each player being indicated by a different color. You basically see that there is a certain variability of the maximal acceleration, which varies between 7 and 8.5 order of magnitude meters per square second, and of course a similar variation on the maximal speed, which ranges for something 8 point something to 10 point something. But before going into more further detail, let's see what this type of analysis tells us. And let's take the mean of the acceleration versus speed profile of these 16 subjects, taking the mean of the maximal acceleration, 7.49 meters per square second, and the mean on the other side of the maximal velocity, 9.35, and draw a straight line between the two. Now, stay on that one, Christian, please. Go back. You can. Yeah. Now, going back to the previous slide, the reciprocal of the slope of this line, which is the ratio between the maximal value of the maximal speed value to the maximal acceleration value, is a measure of the time constant of the exponential increase of the speed at the onset of the maximal run. But this is a somewhat awkward assessment, because with that, in addition to telling us this, the time course of the increase of the speed at the onset of the run, the time constant tells us also the distance performed covered as a function of the speed during the run. The next slide, thank you, Christian. You see, taking the average slope, you see that after 2 seconds, the subject has covered 9.35 meters, and then it proceeds. And after, when he reaches about 5 seconds, he has attained the maximum speed, has covered 35 point something meters, and then it goes up linearly, because as long as he can keep the speed maximal, it goes up with a constant slope. But now this is an average thing. Let's now make a step further and take 2 hypothetical individual runners, one of soccer players, one of whom has both of them having the same maximal velocity, 9.85 meters per second, but one being characterized by a very high acceleration, and hence by a low time constant, and the other, the blue line, and the other, the red line, being characterized by the same speed, but by the lowest of the maximal acceleration we observe in our 16 subjects. Let's see what happens when we calculate now the time, the distance covered as a function of time in these 2 hypothetical subjects. And you see the numbers in the red circles is the gain of the blue subject, the one characterized by a high maximal acceleration, but again by the same maximal speed, in comparison with the other subject, the red one, which is characterized with a smaller maximal acceleration, but again with the same slide. And you see, of course, that once they have reached the maximal speed, the acceleration is 0, the 2 lines will proceed continuously, and they will proceed as long as they can keep the speed maximal without the red line ever reaching the blue line. But you see that, for instance, for the first 2 seconds, the subject with the higher acceleration has gained more than 1 meter compared to the other one. And this goes on like so. But now let's reverse the procedure and take, again, 2 other subjects, this time characterized by the same maximal acceleration, 7.49 meters per square second, the mean between among our 16 subjects, and 2 extreme values of the speed, the maximal speed of 10.46 for one subject, and the minimal speed of 8.30 by the red subject. And let's do again the same thing. And you see that in this case, the gain of the subject with the high speed is much smaller. After 2 meters, he has gained only 88 seconds, and so on and so forth. In this case, of course, since the subject is characterized by different maximal speed, the one which has the highest maximal speed keeps, once the maximal speed is attained, as far as he can keep it, he keeps increasing his advantage. But let's now see what happens, and in comparison with the other example, you see that after 2 seconds, the gain of the the previous case was 1.25 meters with a high acceleration and a relatively low maximal speed, as compared to only 0.88 when the speed is highest and the relatively low maximal acceleration. And of course, things go on like that, but the faster runner, after a while, keeps advantage and keeps increasing the speed. So what does this tell us? This is the practical application. That for short distances, hence short times, is much better to have a high acceleration, even if the speed is a little bit lower than in another case. On the contrary, for longer sprints and longer times, it is, of course, much better to have a high velocity, and even if the speed is relatively low. A high maximal speed, even if the acceleration is relatively small. So, since I believe, but I'm not an expert in training, that with training we can increase both maximal acceleration and the speed, the question that will be addressed in the next talk by Professor Morin himself will deal with this problem. Is it better to improve maximal acceleration or maximal speed? Of course, simple question, both. Thank you for your attention.
Thank you, Professor Di Prampero.